Everybody to the fifth session of our Make Azure AI Real series. This series, I made this up in the first episode. I'm just running with it all the way through. But this series is about not just talking AI, but doing AI. And today we're going to do Azure AI Cognitive Search plus ChatGPT equals. I will have to see, but the man who's going to show us what that equals is Matt. Matt, how are you doing? Welcome to Make Azure AI Real.
I'm doing really great today. Thanks so much for having me on the show. I'm really excited to show you guys what we have. There's been a ton of excitement in this space. We have so many people interested in this chat your data thing. So really excited to talk to you about it.
Awesome. So this is your first episode. It's not my first episode. I've been here for all five. But here on Azure AI Real, we like to do a little warm-up question just to get the blood flowing. So we have a question and it's always going to be a little bit relevant to what we're going to talk about, sometimes random. But today's question is about if you're like, what sort of new skill are you learning? So let us know in the chat, whether you're on Twitch or YouTube, just put in the chat if there's a new skill you're learning or trying to learn, or maybe you just learned, you just like mastered it. I don't know. But Matt, the question goes to you as well. What new skill are you learning?
Lately, I've been trying to learn some yoga. So I've been getting up early in the morning, usually around 6 to go to yoga class. And it's been a really wonderful experience. There's nothing like great movement to start the day.
For sure. And breathing and flexibility, how's that going for you?
It's been challenging, but fun. Definitely getting a lot more flexible. A month ago, I would have been really surprised I could touch my toes now. So that's fun.
Yeah, that's an achievement. That's like when you go to, if you're learning a new skill, you need to have like levels of like, beginner, intermediate, advanced. And like, I'm actually on a level now I can like reach other. Well, I've been failing at trying to learn piano. That's my new skill. I bought a piano like maybe July, and I've played it once. So
Like a grand piano?
no, not a grand piano, but it's an 88 key electric like keyboard. But it's like I did tons of research to find it. I was like, this is the one. It has like the perfect weight, so it's not like plasticky or anything like that. Played it once. I see it every day, so it's a good reminder to keep going. But yeah, you gotta you gotta keep practicing, and even with this AI stuff, it's good to get your hands on, and that's really what this series is about. So another question we always ask is, what does making Azure AI or this AI real for you? What does that mean to you, Matt?
For me personally, making AI real means I can actually do cool stuff with it, right? So I'm a huge nerd, right? I work in a tech job.
I'm not the
I
only
really
one. Not the
love
only one here.
learning. Yeah, I love learning in depth about stuff. And it's one thing to kind of read a paper and say, oh, that's super cool. But it's a totally another thing to say, okay, here's how I actually apply it to like a problem I have, a problem my business has, something else. And I think what's really cool about Chat Your Data is it's kind of like a universal tool where you can basically take anything you want and like kind of break it down and understand it using ChatGPT or any language model. So what I have for you guys today is this kind of demo I wanted to show you. And if we switch to the screen.
Yeah, let's do it.
So basically what we have here is we have a kind of set of tutorials here. Basically, we want to learn how to chat with your data. Thought about doing a PowerPoint slides. I do have some slides we can go into, but
It's ready. It's ready to go if we need to show
it. Ready to go, absolutely. But I really wanted to kind of showcase the power of this chat with your data paradigm. So I have a lot of topics. What I basically did was I took some papers, some blog posts we've released at Microsoft, and I've kind of thrown them in a series of PDFs. We've done some kind of special pre-processing on them. We've gotten them basically ready so that ChatGPT can understand them. So if I were to ask any question, right, teach me about language models. Well, I want to have an interactive tutorial. I want to talk. So I've kind of pre-cooked some answers and responses, but basically what I want to show you guys is that if I want to learn something new, like how do language models understand and generate text like humans, I myself don't need to go and read in depth. I can actually, using the Chat Your Data app, I can actually just give it the document and ask it questions rather than reading. And I think this is a super powerful tool. I personally love talking to people rather than just kind of watching lectures. So creating this kind of interactivity with just plain documents, it really adds a whole new dimension of interactivity that wasn't there before. So if I look and I say like, well, hey, look, like I have all these facts like about how to train language models. I think something people have figured out about ChatGPT at this point is that it's really good. It knows a lot, but it has the potential to make stuff up. And this is something that we think is a huge problem. So the way we mitigate this in Chat Your Data is we have these citations. So I can actually click and I can go back to the kind of source document that I was actually reading, and I can actually read myself where it's going. So if it says, it's like, hey, I have vast amounts of text data. If I actually scroll up, I can actually find where it's actually citing that, right? Trained on a data set of 8 million web pages. So I don't need to take ChatGPT at its word. It can be used in that way. It has a lot of knowledge about the world, but we're much more comfortable with it when we actually have citations. It's a pretty powerful tool. Like, it generates follow-up questions. So clicking through these, like I could basically kind of go through this interactive tutorial of basically saying like, I want to learn how language model training works. So I'll have it do the heavy lifting and kind of summarize for me. And then I can kind of go and read the parts I'm interested in.
Nice. And I think you mentioned it because I mean, a lot of people, when they see this, then they get inspired or see use cases that they maybe could apply to themselves. What's been in the process? Obviously, I see these are PDFs, but what's the process of actually like the pre-processing and getting these PDFs for the language model to understand?
That's a great question. So I kind of want to switch gears a bit and let's jump straight into some code. So basically with this repo, this repo is actually kind of a shared project. It's an open source project. So if you go into the link that's provided, the Chat Your Data intro repo, we basically have a whole kind of maintained by a Microsoft Azure Search OpenAI demo. So I actually forked it, called it Chat Your Data intro, and I removed some stuff, but I left this kind of script called prep docs in there. And prep docs is super interesting because it's kind of a hairy script, but what it does is it basically handles the whole, hey, I have a bunch of PDFs. I need to actually index them so that they're actually searchable by ChatGPT. And kind of at high level, what does that mean? I am actually ready to switch to my slide deck to kind of show you guys. So we have this whole generative AI thing, like it can do a lot, but when it comes to your data, it doesn't really know about your data out of the box. So basically, the way we kind of solve this problem is by using a pattern called retrieval augmented generation, where essentially we pair two things together. We have something called the generator, which in this case is the Azure OpenAI ChatGPT, and this thing can generate text. You prompt it, you say like, hey, ChatGPT, tell me what life was like back in the 1800s. And it will generate some text in your response. It will answer your question. And there's a lot of very fancy things they've done to get it to respond to your question. That's not something you get for free with language models. So it's very impressive work done by OpenAI. But even with all the work they've done, it's very hard to keep fresh because these training processes for these models are so long and hard. So what we do is we pair it with something called a retriever, in this case, Azure Cognitive Search, which is our cloud search solution. So I can bring my documents. In the case of my demo, what I did was I brought my documents as in a bunch of papers that have been basically doing research on language models, chatting your data, stuff like that. And by putting them in Azure Cognitive Search, I can now basically say, hey, when I ask a question, the first thing I'm going to do is I'm actually going to search for the source documents, and I'm going to find the relevant source documents to my question. Azure Cognitive Search, it's got a lot of features for kind of basically finding the most relevant documents for your query. So once we find those relevant documents, we kind of chop them up and actually hand them to ChatGPT alongside my question. And in a nutshell, that's how Chat Your Data works. It actually looks relatively simple in code, so it could be surprising to some people, but you can do a lot with just kind of these two components together. It's a very powerful paradigm.
I think one of the questions we always get for this type of using RAG is, what if the model doesn't find anything in context or in the documents to answer your question? Does it go now to the internet to find things, or how does the model handle like answers that it doesn't know or questions that it doesn't know the answers to?
That's actually a great question. So There are a variety of patterns for dealing with this problem. So the first thing you have to think about in any kind of retrieval augmented generation app is you only know what's in your knowledge base. And in this case, your knowledge base, Azure Cognitive Search. If you don't have documents in it that answer your questions, in our demo, we actually, if I switch back to the code here, we actually have kind of set up our prompt so that we want to give up rather than give an incorrect answer. And why would we do that? Right. So I think when it comes to chat your data applications, a lot of the customization can actually happen completely in natural language, like no coding required. So in this case, we want to ask the question of basically saying like, hey, don't do not cite I cannot find the exact string, but essentially we actually tell it in natural language, don't cite stuff you don't have access to. So this is a common problem in language models. It's called hallucination. And basically a way to mitigate that hallucination is to combine grounding context from this knowledge source. In this case, like, hey, I retrieved documents relevant to my query, and I gave it instructions in natural language to say, only use the sources that are present in the prompt I gave you. Now, obviously, this is not bulletproof. The thing about language models is that it's all probabilistic. You still might get output that it might not be parsable by you. It might be wrong. So this is why the citation pattern is so key. We always want people to be double checking what these things are saying. We don't want them to be taken at face value.
Nice. I know, Matt, when we prepared, I said I was going to ask some softball questions, but I can't commit that the audience will ask you hard questions. So we do have some pretty good questions coming in. So one of the questions is, and this is actually, I think, a really good one for everyone entering this space, because there's so many different vector stores out there, whether Microsoft or non-Microsoft. Do you know anything about the differentiators or like the differences between other services like Pinecone, Foss, Weaviate, I believe, as well?
Absolutely. And I want to refer you guys to this blog post. We actually had a Make a Real session about this very blog post last week, I believe. So I hope I can share the link with you guys. But essentially, we've actually measured against kind of standard vector retrieval. And a key differentiator of our platform is our remaking capabilities. So if I go back to my demo and I show you guys basically in the developer settings, I've cut some stuff out from the demo I forked it from. But essentially, there's this feature called use semantic ranker for retrieval. So if I turn on the semantic ranker, I essentially am able to get much more relevant results. Why is that? Well, basically, the way cognitive search works is there's two layers of retrieval. The first layer is the kind of standard vector / BM25 retriever. So if you guys aren't super familiar, basically the way a search engine works is there's two general ways. Number one is kind of a bag of words approach, where we basically say, hey, given a document, split it up into tiny words and basically build an inverted index. So I search a query. It's like, hey, the query has the word hello. Find all the documents with the words hello and return it. It's a little bit more fancy than that. We use an algorithm called BM25. So basically trying to match the documents that fit the query based on terms or words. The kind of way we've recently added to our product is vector search, where it's okay. Now I'm going to basically break up my document into smaller pieces. I'm going to basically create a vector that best represents those pieces. And how do I do that? Well, we can actually use Chatter data to find out. So in this demo, I actually have a whole section about embeddings. Embeddings are essentially what enable vector search to be so powerful. Effectively, they are numerical representations of any concepts. In this visualization, you have some kind of text. In this case, it's Spanish. Veneti and amigos. It rolls through an embedding model, and we get this kind of sequence of numbers, this vector out. When I have this vector, what I can do is I can now put it in a specialized vector database. Azure Cognitive Search has this vector database capability. And I basically am able to, how do I use these embeddings in the database? Well, the number one way we want to use these embeddings is something called semantic search. Because every sentence or you can kind of break up the text however you want. We call it chunks. we map it to this vector space. And the idea is that in vector space, you basically have clusters of similar sentences. So when you search like a query saying, hey, hello, find all the documents that are semantically similar to hello. So they might not have the word hello. It might be like aloha or something like that, like another language. But if the embedding captures the meaning of hello, it'll still return that document. So in that way, vector search can actually outperform just standard term-based search. But we find in our testing that that's also not enough. So even combining these two methods together to get hybrid, you're getting the best of both worlds. But what we find is that you need a second step, which we call L2, where you basically take the output of this hybrid step and re-rank it. So what happens is we basically say, hey, here's the documents that we returned to match this query. We're going to basically run it through our Bing models that actually, it's kind of similar models to what you use for Bing search. And it basically takes in the original query you sent. It takes in the documents. And then it says, hey, you know what? For this query, we actually think the document that Azure Search put in the 5th position, it's actually the best result. And when we benchmarked it against Beer, which is a really common information retrieval benchmarking data set, we found we can kind of outperform the competition. Just uses standard cosine similarity.
Wow, nice. I'm glad you were super prepared for that answer, for that question, for sure.
Yeah.
Then the other question, this is a follow-up before I go to another one, but I think I've seen also around the differentiating between different products is actually how the data is ingested. So, there's one way when we have static data, but if you want to update the data and things like that, like what's a differentiator between that and what any sort of best practices have you seen?
Yeah. So if I look, basically we have different paradigms for dealing with this, right? So essentially, if the data source is not static, we have a managed data ingestion solution called indexers. And basically what it does is it kind of takes data in from this data source that's dynamically changing, and it runs through it and puts in a target index. And we have kind of samples of basically how to use these indexers to kind of vectorize the data and put in the index. You're also free to use just a standard text-based retrieval strategy, and in that case, you don't even need to worry about that. But the idea is that you have some kind of scheduled refresh process, right? This indexer, and it's basically polling your data source for changes. If you have a data source where you kind of get notifications about change, you're welcome to use kind of like a push-based API solution where basically you say, hey, the data's changed. I have to actually kind of collect the update and do it myself. So it really depends on the data source, I would say. There's not really a one size fits all because if you're looking for something like a real-time update-based solution, it's probably going to look a lot different than kind of our indexer pipeline, which kind of is a scheduled refresh. But that's a great question. I think the key to RAG is having an updated knowledge base because your answers are only as good as your knowledge base.
For sure. Yeah. That answer had two of my favorite things, right? The best answer, it depends, and two, the quality of data is where it all starts. So,
Yeah.
And the last question before we get back to the whole presentation, this one's I think a bit more straightforward, but what temperature is recommended when doing RAG? And just for anyone who doesn't know, temperature really talking about like essentially the creativity or leniency or flexibility of how the model handles the questions. Mhm.
Yeah, I mean that's a great question. So I'm actually going to go back to my little demo and kind of go back to my answer
Perfect
about like, well,
segue.
how
Look
are
at
language
that.
models trained, right? So effectively, when we say temperature, right, like we talk about like, okay, well, there's this idea that language models are predicting the next word. I actually think that's a bit understating what they're doing because there's so much that goes into training these things. But to make it really simple, we're talking about predicting the next word. And there's this probability distribution that these language models have, where it's basically saying, hey, uh, language models kind of see the world in terms of tokens, which is kind of like the minimum unit of text you can put in a language model to predict the next token. It might not be a whole word. It might be like a comma. It might be even a space. It might just be the word the. But essentially, these models, what they do is they take in these tokens and they take into account the position of all the tokens in the input, and they use all the information they're given to predict the next token, which is why they're so powerful. When we talk about temperature, we're talking about basically this probability distribution that the model is using to predict. Essentially, there's this concept of I could pick the most likely next token or I could not. So temperature is one of the many tools you have to kind of change how these models are using the probability distribution to pick the next token. When it comes to RAG, unfortunately, the answer is it depends. I feel like most of the chat your data scenarios I have personally seen, people want facts. You want to kind of go with where the probability distribution is pushing
Right.
you. If you're looking for a more creative response where it's like, oh, I want you to like rephrase how this document says this, higher temperatures might be a better choice. It all depends on how this probability distribution, you kind of, it's really something you have to play with to get a sense of how it works for your particular data. And your past experience on one knowledge base might not apply to the next one.
Awesome. That's good to know. The questions are keep coming in, so I'm going to take another one before we get back, because what's about the show is that people they want to get answers because they want to build something, hopefully. So
I
it's
love
good
it.
to see. Yeah. So another question is, can we connect Azure Synapse and Delta Lake, so the cognitive search Parquet file formats? Can we connect those things? Do you know
This
that?
is a great question. My suspicion to this question is, as of today, not right now. I do know there is an Azure feedback form. I don't have a link handy, but this is a great thing to file feedback for because we want to hear from you if you have a desire for a connector. Because here's the reality: like you can implement RAG refresh however you want, but it's much easier to use our built-in solution. So we totally hear you. Like we want to meet you where you are. We want to support the file formats and the data stores you want. So filing this feedback for us would be super valuable. And I'll actually make a note of this one so that I can kind of look into it.
Nice. Is there a place where people can see various connectors, or is there like a docs
Yes,
page or something
there
like that?
is. I think we have like a data sources gallery. Let me see if I can find it. Yes. Okay. So this is I'm gonna send it to you, and I don't know if you can ping everybody in the
Yeah,
chat.
Ma's
This
got it
is
in
our
the
kind of
chat there.
data.
So
Yeah, we have a data sources gallery where we kind of list, hey, here's the status of all our data source integrations. So please give this a look. And if you don't see something here that you want, like let us know. Um, we love hearing your
nice.
feedback.
Cool. Well, this is like becoming a rag therapy session. So we're just gonna keep going with these,
Yeah.
and then if people, I mean, this is what people come for the answers. So, so if a user asks two questions about unrelated topics, and the third question is I just referred to it pointing to the first question. So I guess maintaining the context of the chat, the newly generated follow-up question is not effective. Any ideas here?
This is an excellent question. So I'm going to go back to my code. So it's like, well, how do we generate follow-up questions, right? And it boils down to we're really dependent on how these prompts are written to give good answers. I can tell you one of the most effective things you can do right now to kind of improve your quality is I have a specific instance where it's not doing what I want, giving examples. And giving examples to these models completely changes the game in terms of performance. And what do I mean by that? Well, I'm going to go back to my Chat Your Data app. What's the difference? There's a term in literature between few shot and zero shot. So if I ask the model, generate follow-up questions for this, so if somebody gives me a question, it's like, okay, generate 3 follow-up questions using all the context provided. Basically, what is happening is it's going to make a really educated guess as to what you want. To most of the time when we prompt, we kind of intuitively want to use something called zero shot, which is basically I ask the model to do something and I expect it to know what to do. Few shot is a bit different because in few shot, you give it examples. So in your case, hey, you know what? I have this specific instance where I'm not getting the follow-up question I want. If you give the model an example of here's what I don't want, here's what I do want, chances are it's going to perform a lot better. This kind of all boils down to the magic that is in context learning. It's kind of this new paradigm of machine learning, where basically we're taking advantage of all the knowledge that these models have built over time, and it's learning how to do things it wasn't explicitly trained to do. Like, nobody went to ChatGPT and said, you're going to be really good at generating follow-up questions. It happens to be good at that because it knows a lot about the world and it's seen a lot of examples. It once again, it goes back to this hyper advanced training process that OpenAI has performed. So the fact that it works well at all with zeros out learning is super impressive, honestly. Few shot kind of takes it to the next level. So if I were in your shoes, I would try giving it examples of what you do want and see if that helps.
Nice. And I don't know, maybe you have an in the code itself now, but like an example of a few shot example,
Yeah.
or like how could people sort of
Yeah.
understand what those typically look like?
So in this case, this is a one-shot example, but I basically say, hey, I want the follow-up questions in a specific format so I can write code to parse it. And I give it an example of some follow-up questions I wanted for this tutorial, actually, like what's an embedding? Why don't I get consistent responses? How can I avoid going over the token limit? So by giving it examples of what I want, I'm conditioning the model to output text that looks like the examples. And again, a little bit oversimplifying here, but that's a really useful way to think about it, because few shot tends to be a lot more effective than zero shot.
So would you say like maybe the model can grab its, like touch its ankles, but you're helping it touch its toes, if we go with the yoga analogy?
That's a great analogy, actually.
Yeah,
And
that's
all
why
these
I'm here.
things, RAG, few shot, like Andrej Karpathy, I actually have a link to his zero to hero tutorial over neural networks in the repository, which I actually, maybe you should send it to your viewers, because I think if you want to learn about how these things actually work and like how to the next level, like his tutorial is probably one of the best.
Is this like
I
the build your own GPT, or which one is this one?
Yes, it's a whole
Okay,
eight video series. Super interesting. He's a really smart guy. Highly recommend his series.
very nice. Yeah, that I do recommend anyone, especially in the space. Like, I think there's another like build rag from scratch or something like that tutorial I've seen as well. But like building from scratch from a lot of these things will give your understanding so much more. I mean, the tooling is there. Obviously, we're building a lot of things to make extrapolate some of the difficulties. But once you get why those tools exist, it really kind of, to the point of learning, brings your learning to the new level, I think, for sure.
Mhm.
Cool. So what else do you have to show for us? We don't have a question yet, but we'll probably get
Okay.
more coming soon.
So you guys are super excited. So I want to jump right into demos. So moving away from kind of the app. So basically what I wanted to show you guys is kind of more free form. So rather than kind of moving away from the user interface, like let's just talk about code, right? So I want to talk about two things that I think are super interesting. Number one, like I want to get more of an intuition with you guys about embeddings and how they work. Like, how do I actually like think about taking text and kind of moving to this vector space? Because honestly, that's probably one of the most critical parts of RAG, because in order for RAG to work well, retrieval augmented generation, you need really good retrieval quality. And it's really hard to beat a combination of these kind of dense retrievers, which use vector search, and BM25 based text retrieval. Combining those, but plus the re-ranker, like that's kind of the way to do it. So we want to understand how to generate these embeddings super well. So I've got this demo where I actually take that blog post I showed you earlier, the outperforming vector search blog post, where basically I want to actually get the text out of it. There's lots of ways you can do this. In the script in my repo, basically we use something called Azure Document Intelligence. In this case, I'm using just an open source Python repo called PyPDF. And I literally just kind of open this PDF, I kind of read the text, and I just put it in a single string. Now, the problem with doing it this way is that the models that actually produce embeddings, they cannot take too much text in at one time. They will fail because they've only been kind of trained to deal with small amounts of text, small amounts of tokens at a time. So what we do is we need to kind of have a strategy for taking a big document and breaking it up into smaller pieces. So in this case, I'm using a library called Spacey. It's a really good natural language processing library for Python. And I'm doing the kind of most obvious thing here, which is I am breaking it up into sentences. So what does that mean? I literally just use the model that they have produced, an English language model, and I break text up into sentences. And I'm not going to run it here because I've done some more pre-processing. But basically, if I look in this JSON file, rather than dealing with the PDF, which is kind of hairy to deal with, I'm actually going to just deal with sentence text. Next, what I did was
Is there any other ways to sort of break down these texts other than in sentences or other methods?
Great question. I've actually switched to the slide deck to talk about that.
Yeah, got it.
Let me see here. I think this is near the end. No, I apologize. I cannot. Here we go. We're gonna talk about some of this stuff here. Okay, so basically, looking at document chunking, right? So here's an example of kind of like some text, and this is the original demo file where it was basically fake health plan information. So this is a kind of a snippet of text from the original files with the Azure Search OpenAI demo. And what you can see in this visualization is you can see actually, I was talking about tokens earlier. You can see how ChatGPT actually views this text. And it doesn't look at the text at all like we look at it, right? Like some words that we see as whole, like Northwind, and what was another example? It's just basically weird breaks where like Northwind is in two parts, north and wind. But basically every single one of these tokens counts towards your limit. The limits are always increasing. I know there have been some limit announcements very recent, but you still have to figure out how to deal with these. And it boils down to chunking. So the two general strategies we recommend are splitting by sentence. Apologies for the display.
The chunking was off on the formatting. I think that was this is art. This is art in motion.
Art in motion. So I apologize. In PowerPoint it did not look this way. Sorry about that, folks. So I am talking about the sentence splitting strategy because it is simple. Because you can literally just go to a language model and basically ask it to split text by sentence. That's something that's pretty well understood. Another effective method we find is this kind of split by section. And what's a section? A section is essentially taking advantage of the fact that we understand how documents are structured, right? There's headings, there's paragraphs. In this case, the simplest way to define a section is by paragraph. So I've broken it up into two paragraphs, and there's some highlighted green text. Basically, when we talk about chunking, we want the embeddings for each chunk to really represent the content super well. And because our chunking strategies are flawed, right? A piece of a document doesn't represent the entire document. We try to mitigate that with a bunch of various strategies. A popular strategy is overlapping content. So I basically take the content of the next paragraph and I kind of concatenate it to the previous one. So you can see in this example, that's what we've done here. So the hope with that strategy is that your embeddings will represent your content better, and you basically want to boost your chances of getting relevant chunks to answer your question. Because with any retrieval-based solution, you're completely bottlenecked on your answer quality by the retrieval. So it's really important that these embeddings represent your content, because the reality is that if your embeddings don't represent your content, it's going to be very hard for you to overcome that, and your question answering quality is going to be low. So this is another example of a strategy. In the demo, we talk about tables. So I'm not using Forms Recognizer in our kind of little code demo, but if you are using Forms Recognizer, it can actually pull out tables from the PDF. And what we do is we save those PDFs in HTML. Turns out ChatGPT is pretty good at reading code. So if you give it an HTML table, it'll understand what that is, and it can answer questions based on that table. So chunking strategies, again, really depend on your content, but for PDFs, document intelligence / form recognizer is a really strong bet.
Yeah, we actually have one question around tables as well as images. I know in the first example you showed us, there was an image that came in with the answer. So this person has tables, URLs, images. and they've been using the recursive text splitter within the LangChain library, and it just splitting the data arbitrarily does not make any sense. Do you have any ideas or any recommendations on how to fix that?
I do actually. Moving back to the code, I think there is in this prep doc script. We've done our homework here. If you've looked at this demo in the past, it might have been harder to read, but we basically have this PDF parser file. It's all open source. I believe we're under an MIT license. Actually, let me double check. Yes. So feel free to take any of the code in this repo and then the parent I forked it from, Azure Search OpenAI demo, and use it in your app. We use Form Recognizer, and the advantage using Form Recognizer is that it actually handles images, tables super well, gives you structured JSON output that you can parse much more easily. So please take a look at our code and see if this document analysis PDF parser will help you solve the problem. I think the recursive text splitter you're talking about using, it's very good for like plain text files, but it might fall apart on more complex PDFs, and that's where document intelligence really shines.
Nice. And this is the question that we get anytime we do anything in Azure OpenAI, and I always give it to the guest because I've answered this question a lot in my life already.
Yeah.
It's the when is Azure OpenAI going to be, fully available, no request kind of question. So I'm going to go let you take that and see if you've got any other news that I don't know.
I don't have any news. I'm sorry. I am one of the lucky people that gets to use it. I love it. So I certainly hope that we can set up a situation where everybody is able to use it, because it really is a game changer. Like I actually feel kind of bad because I'm going to show you some stuff really soon that I think is some of the most compelling uses of Azure OpenAI, and it's unfortunate that everybody can't use it. That's all I have to say.
For sure. Cool. So we have another question as well about LangChain, some of the kind of orchestration tools, I
Yeah.
guess. Do you see toolkits LangChain hates like better options as they seem more popular versus semantic kernel? I think you're using semantic kernel in this repo, right?
Great question. So this repo does use LangChain. That's true. I think that semantic kernel is also a good option. I will admit I have not spent as much time using semantic kernel as I have LangChain, but I think the way to think about it is you have an orchestration layer. That orchestration layer is kind of one part of your app. I think semantic kernel is coming out with some new stuff. I am not super familiar with it, but I think balancing semantic kernel versus LangChain is kind of a up to you decision. But I think either orchestration layer is super powerful. We use both at Microsoft. I'm less experienced with semantic kernel, so it's hard for me to answer this question.
Yeah, I think all of the options are very much rapidly maturing and also very rapidly changing. So it's like, even if you were to say one is better than the other for whatever reason, probably the next week the other one or whatever tools will probably release a new feature that will contradict what you say. So I say again, get hands on with both of them, see what you're kind of vibing
Yeah.
with, and go with that, I think.
Mm-hmm.
All right.
So let's get back to our little demo. So we talked about chunking. So we've chunked our blog posts into sentences, and I've got some code here. I've already run it, so I'm not going to run this cell. But basically, what it does is it uses another open source library called Sentence Transformers. Sentence Transformers is a really cool library. If you have not heard about it, I would highly check it out. Basically, it lets you run models, just any kind of machine learning model, locally very easily in Python with like minimal knowledge of anything. So literally super simple code. This model is a really popular open source model for embedding sentences. So I basically download it, run it locally, and I also have my Azure OpenAI set up. So I basically, what I can do is I can basically run through every single sentence, and then I'm going to embed both of them. And the goal here is to kind of showcase, hey, there's different ways of embedding data. Like, yes, I've chunked it, but like the embedding, you also have optionality. text embedding Ada002 is kind of a state-of-the-art embedding. Just ask the chat in my demo app. I threw the press release from OpenAI in there. It's got a lot of very positive things to say about Ada002. It is a great model. So the goal is to kind of understand, it's like, well, how do you actually compare embeddings? So I picked four sentences from just arbitrary sentences from the blog. They're kind of similar. So one pair is about ranking. Okay, ranking, also called L2, takes a subset of top L1 results and computes higher quality relevance scores. The second sentence is the L2 can improve the L1's ranking because it applies more computational power to each result. And an interesting exercise is to ask these embedding models, well, how similar do you think these two sentences are? So the way we do this is through a technique called cosine similarity. What is cosine similarity? Going back to trig, basically find the angle between two vectors and basically how close are they. So cosine similarity, it's a number between 0 and 1. It's super useful because it gives you an idea of how similar two embeddings are. These embeddings are in super high dimensional space. I believe Ada is it's about 1,500 dimensions. The mini LM one is about half the size, but you cannot compare two different embedding spaces directly. So what I can't do is I can't take an Ada002 embedding and compare it to a mini LM one. That doesn't make any sense. But what I can do is I can take these two embeddings of each sentences in each space and compare them and see. The goal is to basically say, how do these models see the world? So according to mini LM, you know what? Ranking, also called L2, and the L2 can improve the L1's ranking. They're pretty similar sentences. I'm going to score it 0.72 out of 1. Ada thinks they're even more similar. It thinks, wow, they're almost the same thing. And that has to do with how these models were trained, again, how they see the world. The second sentence, which is, okay, the L2 ranker can only reorder what the L1 is found, and then the L2 ranking is critical for RAG. You know what? Mini LM, it doesn't think they're very similar. Not at all. Ada thinks they're super similar. So the choice of embedding model you make has a huge impact on your RAG application.
That's
This has
That's
nothing
crazy.
to do with your retrieval strategy. This has everything to do with your embedding model. So it's really, the lesson here is it's really worth it to just try out embedding stuff and see how your intuition goes with cosine similarity. Like, I think these are similar, but the embedding model doesn't. You're probably on the wrong track. Sorry.
No, that's really good to do in code. I think there's a lot of, I mean, for obviously the LLMs itself, the models, but like a lot of benchmarking and a lot of not controversy, but debate on how to properly benchmark these things. And you know, like we've been saying the whole time, it depends, right, on certain things. But this is like clearly showing you why it depends and which like you can choose which route to go, which embeddings to use. So that's really super impressive to how different it is in that second sentence example.
Yeah, absolutely. So if I go down here, I've got another cool thing to show you. So there's this really cool library in Python called Umap. And what is Umap? So remember how I said that, hey, Ada is over 1,000 dimensions. I am not a super dimensional being. I can't see in more than 3 dimensions. I don't think anybody else listening can. So the cool thing about Umap, and this is a really cool visualization. I wish I had something as cool as to show you. It can take these embeddings in higher dimensional space and bring it back down to earth so we can understand it. So what you're seeing here is you're seeing clusters of embeddings of clothing. And you can see that, like, hey, guess what? Related embeddings in 3-dimensional space are close together and they're far away from stuff that doesn't seem the same. So it's a super useful technique for kind of understanding what your embeddings actually feel like. You get an intuition for it. So highly recommend checking out Umap. I have some very simple sample code here. So I just take every single sentence embedding and I plot it in 2 dimensions. And what I see is that for the local perspective, and the colors just correspond to the sentence ID. So darker is kind of further along in the document and lighter is earlier on. And what you can see is that the shape of the embeddings where they're being plotted, it's actually it looks kind of similar, but you can tell there's a very clear difference. I can't discern much from these graphs, but what's obvious to me is that these embeddings clearly see the world very differently, and it just kind of drives home the point that it's like, hey, I can use if I had labels where it's like, oh, these sentences are a good fit for this question, I could actually have a more advanced visualization where I'm like, hey, to answer this question, I want to return these documents, but the embeddings that are matching this document are like far away. So visualization, checking cosine similarity, these are two really useful tools that you can use honestly right now to get a better understanding of your data and how it's embedded. And that's critical for RAG. Probably one of the more important things.
Nice. This is taking us back a little bit to the chunking part, but one of the questions was how to come up with a hard threshold for search scores to make sure unrelevant chunks, so the chunks that aren't going to be maybe not past the LLM, for generating responses.
That's a great question, and it boils down to testing it. Now, I think some of the state of the art, which I unfortunately have a demo for you, is basically using language models themselves as judges. So you basically say, hey, given this query answer pair, is it a good result? And the theory is you give it enough query answer pairs, you can actually derive this threshold objectively. In practice, we find people just saying, you know what, if the score was above zero 0.8, it's fine. So you can kind of go as simple or as fancy as you want. I would vote for starting simple first and seeing if that works. Like picking a threshold. The key is testing. If you don't have a way of kind of objectively testing it and you're just kind of like giving it random questions, it's going to be really hard to come up with this threshold. So developing a system around building this threshold, because at the end of the day, you do want a number of like whether that's 0.75 or zero 0.6, like what's the quality bar. And this is something that might have to be adjusted over time as your knowledge base changes. So unfortunately, no kind of hard and fast answer, but
Yeah, and I think this one's gonna go fall into that it depends category as well. But are there any guidelines, decision tree on selecting the selecting an embedding approach or embeddings model, like when we are comparing these two?
so I could tell you that like the larger kind of AI organization, we have AI Studio, and I believe there is going to be stuff in there that will help you answer this question. Uh, for now, kind of locally, I think just manually computing embeddings, running cosine similarity, running some Umap visualizations, that's a good way to get started. But I think as AI Studio matures, you're going to see some stuff that will help you make these decisions, hopefully soon.
Nice. A little bit alpha there, maybe for
Yeah,
the viewing audience.
yeah.
Gotcha. Cool.
Uh,
If you want to
so
take one more here, there's a lot of moving parts within RAG framework. A lot of new techniques come up every week, which is very true, I guess. How do you evaluate chunking strategy, chunk size, many others in generating a better response?
Yeah, that's a great question. So, uh, I think when it comes to new techniques, it's always good to experiment, but it's really critical that you kind of have a baseline approach. You have some kind of really high quality questions and answers that you basically you want to kind of ground truth set to run your test against. So it's like, hey, I've got a new RAG approach. It answers this question really well, but the key is having that database of questions and answers that are really important to you so that you don't kind of regress when you switch to a new approach. So it really boils down to, can you actually have an evaluation strategy when you build when you want to evaluate a new approach? Now, again, like what I don't have for you is I don't have a kind of like one-stop shop product. I
They
think
want
it
the
boils
answers. They
down
want
to
the
like,
bullet. They want the silver bullet. Give us the
yeah,
answer.
absolutely. Uh, I, I, I I recognize like we have a lot of questions. I have one more thing I want to show you.
Yeah,
If
we've got
that's
10
okay.
minutes. So this was super impressive. So if you have something on that level or even more impressive,
Yeah.
let's show that.
So I think I wanted to go into agents. So I think this is one of the coolest things about language models for me. So I was actually kind of cooking this one up because I was really excited about it. So what I have is I have this data set of hotels, and this is part of our demo data set. Basically, it's just a bunch of fake hotels around the world. And I wanted to build, I was really inspired because I saw, I think like Expedia has a like ChatGPT plan your trip. So I wanted to build my own version where I create an agent that has the ability to query Cosmos DB. I want to ask it a question about hotels. It's like, I want to ask it, hey, what's the average hotel rating of all the hotels you know about? And I'll dig in how this works, but basically natural language to SQL, build the query, query the database, and then answer the question. So without any minimal coding, like I think it's less than 100 lines of Python, well, not counting the prompts, but I can literally basically ask a natural language question like, what are 3 hotels that are in New York? And it will give me 3 hotels, like Secret Point Hotel, Peaceful Market, Antiquity Hotel. And I want to ask like a more complicated question, like find the rates for rooms that sleep at least 2 in hotels in New York. Like I'm pretty rusty on SQL, but it came up with this and it was right. It actually has a really nice response. So I can even actually give it other commands like, okay, I want to actually book the hotel. And you notice it's like, okay, I actually can execute the booking where like I gave the date in a different format and it fixed it. Uh, I know we're almost out of time. So really quickly, how do we do this? There's a really cool function in Azure OpenAI called function calling. And what it does is it basically enables these language models to use tools. So in natural language, no coding required, I basically make up something like, okay, there's a query hotels tool and a book hotel tool. I tell it what these tools do, and I say what the parameters are. And it's the best way I can describe it is ChatGPT is playing a text adventure video game with itself. And in my code, I actually basically ask it, okay, given the user's question, what should I do? And I, oops, okay, where am I? Yeah, okay, perfect. I basically ask it, what should I do? So it basically says, hey, I think in response to this question, I want to query the hotels. So then what I do is I implemented another part of this agent in ChatGPT where I basically say, hey, given the question, convert it to a SQL query. And I literally give ChatGPT the schema of my database and I say, hey, find this following information. And I give it a little bit of extra help because it doesn't quite understand Cosmos DB SQL 100% yet. I'm sure it'll get there. But I basically just have it generate the query for me based on the user's question. I run that query. Now, running output from language models, it could fail. So I have some error handling. And I just kind of take the results, I convert it to a markdown table text. I then pass that table back to ChatGPT and say, answer the original question. And I get the answer. And I think this is a super powerful pattern. It is kind of a version of retrieval augmented generation. In this case, I'm not actually querying Cosmos DB for source documents. I'm having ChatGPT generate a SQL query, running that query, getting the results, and then going from there. And I don't have to write any parsing code. I let it do everything. So really powerful pattern where I can actually implement functions in English and have it run the code for me. It's super awesome.
Nice. Yeah, I too am a huge fan of function calling, and this is allowing me. Hopefully, Mel, you have the link ready. But we released a generative AI for beginners course. It's a GitHub repo. Oh, perfect. Look at that. Great timing. And I actually wrote chapter 11 is all about function calling. We do an API request to actually one of the Microsoft Learn APIs and pull back all of the catalogs and learnings that you can have with Microsoft Learn. So you can also, query a database, you can query an API and all of those things. And it's all hands-on, this course, 12 lessons. So do check that out if you want to get a little bit more hands-on knowledge of that, as well as the repo math shared with you. Cool. So we got only 5 minutes left. There's a few other questions if you want to go ahead. We'll round out with these questions then. Any recommended architecture patterns for creating a more highly available or resilient application? And super relevant because I believe OpenAI went down like maybe yesterday or something like that, I guess. So again, making Azure AI real. This is a very real question people really facing on like outages and things like that.
There's 2 pieces of advice I have. So number 1, cache aggressively. These APIs tend to be on the expensive side to run. And especially because the output is non-deterministic, like people get different results. So if you are saving responses to users' questions, you can serve those cache responses if the source is not unavailable. The second thing I have for you is, yes, it's true. Like when ChatGPT goes down, there's little recourse, but cognitive search actually has some extensive documentation about reliability, which I will share with you guys. Reliability and cognitive search. So if I go here, I'll send this to you. Basically, if you provision cognitive search with high availability enabled, you'll be more resilient to data center outages. But yes, I agree with you. ChatGPT outages are very difficult right now.
Cool. And we'll take this last question. Do you see patterns tooling to support agent semantic to allow coordinating working together, like orchestrating coordination DAG-like between different agents? So I guess working with different tools together.
I think OpenAI's announcement about GPTs and Assistant API is super relevant here. I think we are moving in the direction of kind of agents being orchestrated together. I don't see a higher level framework that's like very common right now for putting agents together, but like using this function calling approach, one of these functions could be another agent, right? And you just kind of shell out to it. So I think
Yeah.
the building blocks are there, but we don't have a complete story to tell just yet.
I guess one of the I'm going to finish with my own question, but like with agents, right? Or even function calling, like have you seen best practices on error handling or like actually understanding the process? Like, is there like a verbose command where you can see exactly what the agents or the function it's calling and the process of the model what it's thinking about, and then make corrections if needed?
That's an absolutely great question. And I can tell you that we actually have in our demo a whole thought process tab. So if you are really curious, let me go back here. So if I go here to thought process tab, I think that logging is really important. You can see here that we kind of have the whole like list of commands and like the list of things that it needs. I think that you can look at our demo repo to kind of see how to get these logs for yourself. But at the end of the day, like asking the model to be verbose and kind of like saving these thought traces, whatever you want to call them, it's really useful for understanding your model's thinking process. Because in general, the way models quote unquote think is by emitting tokens. The more tokens you emit, the more thought that goes on. So asking the model to be verbose in the prompt when you're trying to do more complex things is actually really helpful.
Very nice.
That's kind of the best advice I can give.
Well, Matt, so we hit the hour mark. Like I said, this is definitely gonna go. We could have talked maybe for 2 hours, I think, with all the questions we had. So thanks you for being so ready to answer all the questions. I'm also ready with the docs pages, which is I think super super helpful for people to follow up on. And also thank the audience. Like I always say, you could have been anywhere on the internet right now, but you just spent an hour with us too. So for that, we're truly appreciative, and we'll see you in the next Make Azure AI Real series coming up, I think, in 2 weeks. So see you there. Bye.